So the first step to find the resonance, that should be pretty straightforward. We have a formula for that. Resonant frequency is 1 over 2 pi times the square root of LC. Now if I use 0.042 Henry for the inductance, and I use 22 times 10 to the minus 6 for the capacitance, then I get 165.6 hertz. Rounding that off, I get 170 hertz for my answer to part A. But I'm going to keep the significant figures for the rest of the problem. For part B, if operated at resonance, what's the power dissipated? Well, of course, the power dissipated goes as the RMS current squared multiplied by the resistance. And the RMS current is equal to the RMS voltage divided by the impedance. But in this case, at resonance, the impedance Z is just equal to the resistance. And the resistance is just 4.2. And you can verify this. I mean, you can calculate X sub L and X sub C. Just for grins, we'll do that, right? So X sub L is 2 pi times 165.6 times 0.042. Okay, if I multiply those out, and I get 43.7 ohms. And then X sub C is 1 over 2 pi FC, so that's 1 over 2 pi times 165.6 times 22 times 10 to the minus 6. And again, you get to hear my excited punching of calculator buttons. Right, and I get 43.7 ohms. Okay, since they're equal to each other, right, we get Z is equal to the square root of 4.2 squared plus the difference between X sub L and X sub C, which is 43.7 minus 43.7. So that's 0, and Z is just 4.2. Okay, so anyway, the RMS current is equal to the RMS voltage, which we're given as 120 divided by 4.2. So that's 28.57 amps. And so the power lost is 28.57 squared times 4.2, which rounds up to 3,400 watts lost. Now for part C, now we're going to operate at 1/2 the resonant frequency. That is going to knock down the current quite a bit. Okay, so half the resonant frequency would be 82.8 hertz, right? Keeping this significant figures up here so I don't lose any precision. So X sub L, if I calculate out 2 pi FL, 2 pi times 82.8 times 0.042, that works out to be 21.85. X sub C, 1 over 2 pi times 82.8 times 22 times 10 to the minus 6. I already got this calculated ahead of time, so that's 87.37. Okay, so Z is equal to the square root of 4.2 squared plus this difference, 21.85 minus 87.37 squared. And right, it doesn't matter that that's negative because we're going to square it, and that works out to be 65.7 ohms. Okay, so the RMS current is now 120 over 65.7 instead of 4.2 up here, so it's much smaller, 1.83 amps. And so power lost is that 1.83 squared times 4.2. Remember, we use the resistance for power lost, not the impedance, because only the resistor causes a dissipation of power. The inductor and the capacitor just store energy, they don't waste it. So 1.83 squared times 4.2 is a mere 14 watts. Well, less power loss, but a much lower current.